Okay, let us discuss this following reaction. You have to propose the mechanism for the following reaction. So I think let me take another page so this one, so that you cannot see in the background. So basically in this case you are able to see the background. Okay, so let us go for the next problem. So this is writing some mechanism. So you have 14.44. Reaction is given. So you have R, so alkyne you have RC triple bond CH. This is alkyne, and if this alkyne is treated with NaOET minus, so that is Na plus OET minus, and in solvent ETOH, so ETOH is a solvent. If I treat this with, now I am getting a product C double bond C H R, and I have here OET. I think you are able to see this one. OET and hydrogen. Now this product further, if I do hydrolysis, that is HCr double bond COET H. If I do hydrolysis, that is if I react with H3O plus, this gives a aldehyde RCH2CHO. So I am getting a aldehyde. Are you getting? So propose the mechanism for the following steps. So let us try. You see what are the changes that is happening in the first place. You see one change, that is, now this carbon is attached to OET. This is one change. Second change, you see the double bond has, triple bond has formed to a double bond. This is another change. Now this carbon has attached to a hydrogen. So now you know OET minus is a good nucleophile. Even though on alkene and alkyne, generally nucleophilic attack does not take place. On alkyne and alkene we said addition reactions takes place, electrophilic addition. Generally nucleophile does not attack on alkene and alkyne. But in this case I don't have any choice. I have this product. This means there should be, this nucleophile must have attacked on this carbon, then I can have this COET bond. So now using this fact, let us draw the first step. I think you can write the first step. Let us take 30 seconds. And you form up to this step. From here you just form this compound and this compound, both are same. So let us form this compound. So I give you the hint and you have to form this compound. Wait for 30 seconds. Okay, so let us see what we can do is, I have R, C triple bond CH. I don't have any choice. OET minus only it can attack basically, because I need to attack. So this goes here, this goes here. If this happens, what we will have RC lone pair with minus sign. There we will have CH, and then you have to add OET. Now in the next step, this carbon ion basically take hydrogen from water, H plus. So here you have C double bond CH OET. This can takes H plus from water, so you have H2O. Now this takes H plus from water because the medium is acidic. No, it's a ethyl alcohol, so I can take H plus from it, ETOH. Are you getting? Because solvent is not water in this case. Solvent is ETOH, so it can take H plus from ETOH. So you will have RCH. So you see we have generated one OET minus. In the first step I have used one OET minus. In the next step I have used one, I have generated one OET minus. Now this is the first step. Now what is the second step that is happening? You see the second step. Now I have to have, so let us write this one fast and then we will discuss. Okay, I think you have written this one now. Okay, you see what we have in the second step. In the second step, this alkyne again, OET, this OET is gone. So you have RCH2. So I have to add one more hydrogen on this carbon. You see RCH2. Initially I have RCH and double bond is also gone, and I have a double bond O, and OET is also gone. So we have so many choices. I have to remove OET. Are you getting? I have to remove OET, I have to break this double bond, and I have to add one hydrogen. That is enough hint. So what we can do? I have the medium is ETOH, so I can add H plus, and then you do something. So you generate a carbocation. So let us give you a hint. In the first step, what you do is you add a H plus, and you generate a carbocation. And once you have generated a carbocation, try to write the resonating structure for that carbocation, and then in that case you again attack a water molecule and then release ETOH. So let me bet. So what you have to do is you first, so let us do step by step. You protonate this double bond, and once you protonate it, you attack H2O. Done. Do protonation, attack H2O. Then lose ETOH somehow. Okay, let me show you. So what we can do is, so I have this molecule R CH double bond CH OET. So what I am doing is I can take H plus, even though the medium is not so acidic, I can take H plus from ETOH. And the second step I have H plus. You see, the second step is a hydrolysis step. So in the second step H plus is available. Are you getting or not? Second step is a hydrolysis step. I have H plus and H2O. So I can take H plus. So what I can do is I can take this H plus. So I have RCH HC OET H. I can make carbocation here. Why this is so? I have added this hydrogen here on this carbon. So because it will have a resonating structure. This is resonance stabilized, so I can write one resonating structure RCH2 C double bond OET. Now this oxygen will have positive charge, so this is another resonating structure, that is the stable resonating structure, and that's why I am adding hydrogen on this carbon, so that the resonating structure that I am forming is a stable one. So if you have copied one, then I can go forward. So I have now RCH2. Let us write this resonating structure RCH2C and OET plus charge I have here. So water molecule can attack, because the next step is hydrolysis step. Water is already there. So this water molecule can attack here. And if I lose in the same step H plus, are you getting? I am doing slightly one step easier. So I am losing H plus here itself. So if I do this RCH2 CH OH and OET. Now things are very easy. I have already said in the class, on the same carbon if you have 2 OH group or 2 OET group, or you have 1 OH or OET group, that is on the same carbon if you have 2 good leaving group, that kind of thing is not a stable. You have to lose either H2O or ETOH. You have to lose a molecule if the same carbon contains 2 leaving groups. So this is unstable basically, because this is a good leaving group. It can become good leaving group if I add H2O. If I add H2O and if I remove this one, I will get the same compound. You're getting, it will back to pavilion. If I add H plus here and if I lose H2, I will get this compound, and again this compound. So that's back to pavilion. So if I want to lose, I have to lose this compound OET, then I will get a new product. So in the next case, what I am doing is RCH2CH OET and I have OH. Now I can do protonation of this. So if I take H plus, I can protonate this one. Are you getting? So I will have RCH2 CH OH, and then I will have OH ET plus. So this is the next step. Are you getting? Now I can lose OET at the same time. So let us make the molecule again. So what can I do is, so let us make this molecule R CH2 CH OH OET H. This oxygen has a plus charge. Are you getting or not? So this oxygen also has a plus charge. So what can I do in the next step? I have to lose ETOH. So if I lose this molecule, on the same time I can lose H plus, because H plus is a catalyst. So if I do something like this, I will have RCH2 RCHO. So this is the final product that I have to prepare. Are you getting or not? So we have written the mechanism. Now this product is a aldehyde. So this can be a method for preparing of aldehyde from alkyne. So you can use this kind of method from alkyne to aldehyde. Now the essence of the problem is, we have said, so what we have learned from this problem is, generally on alkyne addition reaction takes place, but in certain cases nucleophile can even attack. So this is an example of in which on alkyne nucleophile is attacking. So this is an example of nucleophilic attack on an alkyne. Generally this kind of reaction does not happen on alkyne. So most of the chemistry of alkyne is acid based chemistry, that is if you have acidic hydrogen, so here something like this, in this case, sorry, so in this case you have hydrogen, so I have to take this hydrogen and then I have to make a nucleophile. So this is one part of chemistry of alkyne. Another chemistry of alkyne is addition reaction. So we have two reactions on alkyne. First is acid base reaction and the second is nucleophile generation and attack of nucleophile or addition reaction, the next. And this time we are looking at different kind of reaction, that is nucleophilic reaction that is happening on alkyne, that is basically not usual reaction, it's a extraordinary reaction, it happens well in certain cases. So this we have discussed is a nucleophilic addition reaction on alkyne. Are you getting or not? So that finally So second part of the question says, explain why a nucleophilic reagent such as ethoxide ion acts easily on alkyne but not easily on alkene. So second part of question says, like if you have alkyne, so B part, and alkyne can easily attack on, ethoxide ion can easily attack on alkyne. So in this case, OET minus can attack on alkyne, but it generally does not attack on alkene. So you have R. Or you can have hydrogen here, that is not an issue. Now OET minus, if you take in this case, it does not attack on alkene. Why this is so? If you attack here, what you are getting? So let us see the product and then you can answer. So you will have minus double bond, you will have H hydrogen OET. Here you will have, if you attack on alkene, you will have R minus one lone pair C R H, and you will have OET. Now you see in this case negative charge on sp3 carbon. So what is the hybridization? So this is a carbon and hybridization is sp3. Now what is the hybridization here? 1, 2, 3. So this three groups. One group is double bond, one bond. This is lone pair. So this is on sp2 hybridized carbon. Are you getting or not? So in the one case, negative charge in sp2 orbital. In the other case, negative charge in on sp3 orbital. Which is better one? So which carbon ion is better situation? So most stable carbon ion, which one is the most stable carbon ion? Either sp2 hybridized carbon ion or sp3 hybridized carbon ion. Which you think is better one? sp2 is more electronegative. So more electronegative, more negative charge, that's fine. So sp2 carbon ion. So sp2 carbon ion basically it's a stable one. It's a stable. Why this is so? Because negative charge is on more electronegative atom. It's a stable compared to sp3. So compared to sp3 carbon ion. Why this is so? Because of negative charge on electronegative orbital. So this is a sp2 orbital is more electronegative. Orbital is more electronegative. And that's why this is more stable. So you see why we have a nucleophile, it can attack on an alkyne but is very less chance to attack on the alkene because of the carbon ion that we are generating is on sp3. sp3 is far away from the nucleus, so it's not stabilized. If you are attacking on alkyne, the negative charge that is on sp2, that is the carbon ion formed is sp2, that is not so far away from the nucleus, very close to nucleus. You have 66% character, S character. In this case, sp2 case, S character is 33%. In this case, one is 25%. So you have less S character, more away from the nucleus. So sp2 orbital is close to nucleus, and that's why negative charge can be stabilized. nucleus has a positive charge, so it can stabilize, but the other case it cannot be stabilized, and that's why we have sp3 carbon ion is less stable, but sp2 carbon ion is more stable. So I can suggest, if you have an alkyne and the situation is I don't have any choice, in that case I can attack a nucleophile and alkyne. Generally reactions on alkyne are addition reactions happens generally, or another kind of reaction is acid base reaction. Terminal hydrogen is acidic, we have already said. In alkene it's not so acidic, alkane is very less acidic, alkyne slightly acidic, and that's why chemistry of alkyne is either acid base chemistry or you can have addition chemistry, but this is an unusual chemistry, that is a nucleophilic attack. Generally we will not have a nucleophilic attack. So this is simply to illustrate a mechanism. Sometime if this question only says there is a possibility, sometime even nucleophilic attack can even possible and double bond, triple bond, and very less possible and double bond, because we have said on double bond the carbon ion generated is sp3. So if somebody asks nucleophilic attack, chance of nucleophilic attack, then I will say it is more on triple bond, less than double bond, and even less on single bond. So the chance of nucleophilic attack, so it will go in this direction. Nucleophilic attack on alkyne, alkene and alkane. So it will mainly on alkyne there is a chance. Alkene there is very less chance. Alkane no chance at all. Alkane chemistry is basically radical chemistry. We have already explained in the class. Alkene chemistry is mainly addition chemistry. We'll discuss the next question.